So my topic is usage of Protobuf in Android applications. So the agenda is very simple. I will talk about what is serialization of data, why is it required, what are the most commonly used serialization formats, then what is Protobuf and how it comes into the picture, then what are the advantages and disadvantages of Protobuf, then we will go on to the key features, and then started with Protobuf demo or code walkthrough, and finally we will have a QA. So I need about 20 to 25 minutes for the entire discussion. So what is serialization of data? So I'm sure most of you guys already know about it as you are from the technical background. So serialization is the conversion of the state of an object into a byte stream, which then can be saved to a database or transfer over the network. So what happened in Java, we create several objects that live and die accordingly, and every object will die when the JVM dies. But sometimes we might want to reuse an object between several JVMs, or we might want to transfer an object to another machine over the network. So serialization allows us to convert the state of an object into a byte stream, which then can be saved into a file on the local disk or sent over the network to any other machine. And deserialization allows us to reverse the process, which means application. So serialization process is platform independent. Then an object serialized on one platform can be deserialized on different platform. Now, an object is eligible for serialization if and only if its class implements serializable interface. So serializable interface is defined in java.input-output package. So serializable interface must be implemented by the class whose objects needs to be persisted. So what are persistent objects? Persistent objects are the objects that exist in memory even beyond the duration of the process that creates it. Now, serializable is a marker interface. So marker interface also known as tagged interface. So marker interface and tagged interface are the interface which has no data member and no method. It is used to mark Java classes so that the object of these classes may get a certain capability. So if you mark your class as serializable, it tells the JVM that the object of this class is ready for being returned to and read from storage or over the network. Now, different ways of data serialization. So there are multiple ways to serialize the data like CSV, YAML, XML, JSON, Protobuf, but the most commonly used serializable formats are XML, JSON, and Protobuf. So XML is an extensible markup language just like HTML. So markup means it uses tag to define elements within a document. XML is designed to store data and is popularly used for transferring the data. XML is case sensitive and it is human readable. XML tags are not predefined, like you need to define your customized tag. The extension of XML file is .xml. Now second is JSON. JSON stands for JavaScript Object Notation. So JSON is a file format that uses human readable text for storing and transmitting data objects. The extension of JSON file is .json. So XML and JSON both are text-based data serializable format, whereas Protocol buffer is a binary format created by Google to serialize data between different services. And the extension of Protobuf file is .proto. So I will explain Protobuf in detail in my next slide. So what is Protobuf? Protocol buffers are a method of serializing data that can be transmitted over network or be stored in files. So the other formats like XML or JSON are also used for serializing data, but they are not fully optimized for the scenarios where the data is transmitted between multiple microservices in a platform neutral way. So in microservice architecture, let's say one microservice is written in Java, might want to communicate with another microservices developed in JavaScript or some other language. So by default, all the microservices use REST architecture for their communication by exchanging JSON over HTTP. So JSON is also good. Is it easy to use and human friendly, but it is not machine friendly. JSON takes time to serialize and deserialize as it is a text-based format. So when the payload is big, it gets difficult to transfer the data. So in JSON, we pass key value pair all the time, and presence of so many key value pair makes JSON heavy. So the main purpose of protocol buffer is to share data across programming languages. Now, Protobuf is a binary transfer format. Binary transfer format means the data is transmitted as a binary. So this improves the speed of transmission. So this improves the speed of transmission more than the raw string because it takes less space and bandwidth. Since the data is compressed, CPU usage will also be less. Now, initially, Protobuf was created for 3 primary languages, C++, Java, Python, but over the course of years, many languages like Go, JavaScript, Ruby, PHP, C# have also started supporting Protobuf. Now, the current version of Protobuf is called Proto 3. The definition of data to be serialized is written in configuration file called proto files with the extension .proto. So these files will contain the configuration known as message. That means to support Protobuf, a proto file is needed. So this file describes the format of the data to be shared, and this file is shared or duplicated across the various entities, example web services or client tab that uses it. The proto files can be compiled to generate the proto classes of a specific language. So for Android, it is Java. So this is done through the Proto-C tool. Proto-C tool means proto compiler tool. Now comparison of data serialization format, JSON, XML, and Protobuf. So XML and JSON both are text-based serializable formats. So it is easy for a human to understand, whereas Protobuf is a binary format, so it cannot be understood or edited by a human. JSON and XML both can be parsed without having the knowledge of schema, whereas in Protobuf, we should know the schema to decode, like we should know the proto file to decode. And when it comes to processing, Protobuf has faster processing than both JSON and XML. Like I have read it in the official documentation of Protobuf that it is 6 times faster than JSON. And when it comes to code, Protobuf is short and it occupies less data. And yeah, one more thing, Protobuf is the only data format that supports in gRPC framework. So if you want to work on gRPC framework, you don't have any other option. You have to use Protobuf. Now comes to the key features. So first is binary transfer format. This I have already explained. So binary transfer format means here the data is transmitted as a binary, which improves the speed of transmission. Now separation of context and data. So in JSON and XML, the data and context are not separate. So to understand this, you guys can consider context as data type. So consider this example, JSON example, first name equals to Neelam and last name equals to Kushwah. So when you see this value, then you will get to know that this is a string or Boolean or integer. So data and context are not separate. So in this example, the transmitted data has got an object with 2 properties, first name and last name with values. So this is highly readable, but this can take up more space. So for every JSON message has to provide both of these pieces every single time. And as the data grows, the transmission time will be increased significantly. But in the case of Protobuf, things are different. Like we first define a message in a configuration file like this, syntax, message, then user defined message name and fields. So this configuration files contains the context information. Context information means data type information. So the numbers are just identifiers of the field. So by using this configuration, we can send encoded data as 126 Neelam and 227 Kushwah. So in this case, 1 stands for the field type, 2 stands for the data type, which is a string, and 6 stands for the length of this text. Similarly, 2 stands for the field type, 2 stands for the data type, and 7 stands for the length of the text. So this is a bit more difficult to read than JSON. However, this will take very less space compared to JSON data. Now message format. So this is very important. The data is transmitted as Protobuf based on a configuration known as messages. The messages are kept in a .proto file. So let's look at a message example. Yeah, so here syntax equals to Proto 3. So Proto 3 is the current version of protocol buffer. Then a message person. It has 4 fields or 4 components. ID is of integer type, email is of string type, is active is of Boolean type, and phone is an array of phone number, where phone number is again a message with 2 fields. One is number and another one is type, which is of enum phone type. So from this example, we can say a message is declared with the message keyword followed by the user defined message name, and the components, or we can say fields, are declared within the curly brackets. Yeah, within the curly brackets. And each field, so these are the fields, each fields can be divided into 4 components. So they are field rule, field types, field names, and field tags. Now what is field rule? So in the Proto 2 version of Protobuf, there were rules like required, optional, and repeated that were to be added before field type or data type. So this was optimized in Proto 3 version, and only repeated rule is kept. So a field is said to be repeated if the field represents an array of elements of the same type. And if the field isn't repeated, no rule should be added. Now second is field type. So the data types a field can have fall into three categories. The first is the scalar data type like string, boolean, byte, number, etc. Second is an enum data type. So in our case, phone type. So yeah. So in our case, phone type is the field. What is it? Field type. And the final data type is an embedded message like the phone number in our case. Now, what is field name? So when naming the fields in Protobuf, there are some conventions that need to be followed because these are assumed by the Proto compiler as it generates codes based on the Proto file. So the first convention is field name should be in lowercase. And secondly, if there are multiple words in the field name, they should be separated by an underscore. Now, last is field tags. The field tags are a numeric representation of the field. So there are certain things that need to be considered when working with fields tags. So firstly, field tags must be unique inside a message, otherwise it will give you compile time error. Secondly, they have to be an integer. So in our case, repeated is the field rule, phone number is the field type, phones is the field names, and 4 is the field tag. Now drawback of protocol buffers. So there are only two drawbacks. One is small community and other is readability. So there is not enough discussion regarding issues and troubleshooting. While we find a whole lot of information on JSON or XML or any other language, there is barely any on Protobuf. So it overall lacks of resources if a developer is stuck and needs help. And readability, JSON uses text format. JSON and XML both uses text format and easy to read and understand by humans. So which is not in the case with the binary format. Like it is hard to read and requires study to be understood by the human brain as it is developed for the machines. Now, how it works. So before showing the code, let me explain how the entire code system works within the Android Studio environment. So it is illustrated in this diagram. Let's say to support Protobuf, first a proto file is needed. So this proto file describes the format of the data to be shared, and this file is shared, or we can say it is duplicated across various entities that uses it. So the proto file is then used to generate the proto classes of a specific language. So for Android, it is Java. So and this is done through the Proto compiler tool. So what Proto compiler tool will do? It will generate the Proto Java classes from the proto file. Now you could do that external to Android Studio also and copy the generated file over here in your code and use that. But Gradle plugin for Protobuf is also available, and with the help of this plugin, we could have this set up and Proto Java classes will be generated automatically in Android Studio. So I think this will be the best step. You just have to declare dependency in Gradle and Protobuf plugin. That's it. And once the classes is generated, you can now import the proto classes and use it as your data model object in your app module or in your code. So example app, the proto file. Here I describe a simple proto file with a class containing some strings and an integer member variables as below. Here syntax equals to the current version of the protocol, then package, then message, and the user defined message name. It has 4 fields. So this file is then saved in the app source main proto folder of your project. So this is the default folder from where proto compiler takes the proto file and generates the Java classes, proto Java classes. Now Gradle environment. So in your project root build Gradle file, add the following class path in dependency section. So this is the first step. You need to add this class path in your project's root build Gradle file. Then add this Protobuf dependency in the app build Gradle file, and then this Protobuf plugin at the top. Now the fourth step is to add this piece of code in apps build Gradle file. So this will be used to generate proto classes from the proto file, and with these 4 steps your Gradle setup is ready. So now you can compile your code and you will have access to the proto Java classes. Yeah. So now apps code, serialization and deserialization. This I will show you in my sample project, like how to serialize and deserialize the data. So let me open my Android Studio. Yeah, so this is my root build Gradle file. So as per the slide, first step is to add this class path. So I have added this over here. See, now second step is to add this Protofub plugin at the top, which I have done. And also I've added this implementation. I have added this Protofub dependency. And the last step is to add this piece of code. So this piece of code will be required to generate the Java classes. So now with these 4 steps, the Gradle setup is done. So I will close all these. So now to support Protobuf, we need a proto file. So here is my proto file, person.proto in this directory, app, app, source, main, and then proto, and then here is the person.proto file. And these 3 lines are optional. Let me comment this. So now what Proto compiler will do, it will generate a single class named as person outer class inside tutorial package. This person outer class will be used to serialize and deserialize the data. So let me build this project and show you the generated class. Why is it taking so much time? Okay, so till now it is building. I'm explaining these 3 lines. So by default, compiler will generate only single class with name person outer class. So if you want to rename that class, you can use this line option Java outer class name person proto. So when you enable this line, compiler will generate person protos inside the tutorial package. And if you want some other package, like if you want your proto classes to be generated inside some other package, you can use this line option Java package and then the package. So what Java package will do, it will tell the compiler to generate the proto classes inside this package. And by default, compiler will generate only single class. So with the help of this line, compiler will generate 3 class. So for each proto file, it will generate 3 class. One is the message person, second class is the person or builder, and third class is the outer class, which is person protos. So actually not only one each proto, let's say if there are multiple messages like person, address, so for each message, compiler will create its message class, its builder class, and one common outer class. So if there are 2 messages, compiler will generate 5 class. So this is my generated classes, generated source, proto, debug. So this is the package tutorial and this is the outer class. So this is the generated class by the compiler. So it contains multiple methods, I think, which will be used by the compiler internally to perform some action. But what is useful for you is the getter, setter, and the builder object. So this will be useful for you guys to create the object. Now let me uncomment these lines. So now compiler will create one more package com.neelam.demo, and inside this it will create multiple classes. One is person, second is person on builder, and third is the outer class. See, this is the new package. Then there are 3 classes. For each message, compiler will create message, is builder, and one outer classes. Now my Java classes is generated. Now how to serialize and deserialize the data, that I will show you. Okay, so for serialization, first you need to create the message object, message builder object. So here message is person. So what to do, have to do is person dot builder. So this is your builder object, builder. Now with this builder object, you can set the values like set. So we have 4 fields: name, ID, email, and phone. So let me set all the fields. And then last one is ID. Let's say 1, 2. So this is integer. So now this is your builder object. So now you will get the person, that means message object, with the help of builder. This builder dot build. So this is your person object, Protobuf object. Now serialized Protobuf data equals to person dot 2 byte array. So now this is your serialized data. Like if you want to send this data to some other class, or you want to send this data to server, you can do this. So this is your serialized Protobuf data. Let me print it. Serialized proto data sizes. This is your serialized Protobuf data dot length. So this is the serialization part. Now how to do this deserialization? So serialized Protobuf, you have this serialized Protobuf data. So now what you can do is person1 equals to, you need the proto class to parse the serialized data. So our proto class is person dot parse from, and this is your serialized Protobuf data. Now let me add one more log here. The serialized data is email person1 dot get email. Now name person1 dot get name. Now last was that phone number, phone person1 dot get phone, and last is your ID, person1 dot get ID. Yeah, now let me run this. This is the old data. Yeah, so see, serialized proto data is size is 55, and this is the serialized data. So in this way you can do the serialization and deserialization. And one more thing, let's say if you comment these classes, then only one class will be generated by the compiler. Let me show you how to deserialize from that outer class also. Now this file is generated, person outer class. So it contains person as well as its builder object. Now how you can do this serialization, deserialization is in the same way. What you have to do is person outer class dot person, because this person object is inside this person outer class. Or you can import yeah. See, serialized proto data size is 55 and deserialized data is this.